Hello Year 12. Today we're going to be looking at the formation of esters, which is one of the key reactions of carboxylic acids when they're not behaving like acids. We're only actually covering one specification point today, but it's quite a large one. So we'll look at how to make esters from carboxylic acids, and also we're going to be talking about acid anhydrides. Okay, so esterification. Esterification is defined as a reaction with an alcohol with a carboxylic acid to form an ester and water. And they look like this. You can see that you've got a C double bond O attached to an oxygen that is also attached to another alkyl chain. Clearly this has come from the alcohol and this has come from the carboxylic acid. So this is the general reaction for an esterification. We've got our generic carboxylic acid, our generic alcohol, and together they're making an ester where we've taken this group and it's attached to an oxygen, and water. This is how we draw an ester in a structural formula, but it's not a very clear way of seeing it. We always do this with an acid catalyst, usually concentrated sulfuric acid. And this is sometimes called a condensation reaction, which is a name for any reaction, organic reaction, that makes a small molecule, like water, and a larger organic molecule, like an ester. Now if we look at esterification with the displayed formula, you can see that we've lost water from here, and that these two groups have joined together, creating our ester. You can clearly see that the acid fragment has come over here, and it's got the carboxylic acid, the carbonyl group attached to it. The alcohol fragments come over here. We also need heat for this reaction. So how do we name esters? Well, they take the general form alkyl ethane alkanoate. The alkyl section comes from the alcohol. The alkanoate is named after the carboxylic acid. So in this reaction we've got ethanoic acid. We're adding it to methanol. We get methyl ethanoate and water. The methyl group's over here. The ethanoic group is here. What if we hadn't done this reaction? What if we hadn't seen what we started off with? It's very easy from here because we know we started with ethanoic acid and methanol. So we can split the ester into two sides. The side that contains a carbonyl group and the side that does not. The carboxylic acid group side has the carbonyl group. The alcohol side doesn't have a carbonyl group. So let's look at these two very confusing esters. They're isomers of each other, and you can see that they've both got a propyl bit and an ethyl bit, but which is which? So in this ester, there are 3 carbons on the carbonyl side of the ester and 2 on the other side. So it's ethyl propanoate, ethyl group here, the propanoate group here. In this ester, there's 2 carbons on the carbonyl side and 3 on the other side. So it's propyl, ethanoate. 2 carbons on the carbonyl side, ethanoate. 3 carbons on the non-carbonyl side, propyl. It must have been the alcohol. I think it's easier to look for the carboxylic acid bit first. So what about, in the spec we need to learn about acid anhydrides and how they're reacted to make esters, but first we need to work out what they are. So they're formed by removing water from 2 carboxylic acids, and they can be used to form esters. So here we have 2 molecules of ethanoic acid. We're taking away this water and we're making an ethanoic anhydride. You can see it's got 2 ethanoate groups in it that are joined at the same oxygen. When we write that in the structural formula, it looks like that, which is quite confusing and easy to be misleading. But you can see that you have 2 of these groups attached to 1 oxygen. So if you look at it for a while, it makes sense. But how do we make esters from acid anhydrides, and how is it different? So instead of producing water as our side product, we make a carboxylic acid molecule, and it will be one of the molecules of carboxylic acid that was originally in our acid anhydride. Now this shows the mechanism for it. You don't need to know the mechanism, but I think it's quite interesting. Our alcohol has come into our delta positive carbon on our acid anhydride, breaks this bond and forms our ester, but that also leaves a carboxylic acid. Now Acid anhydrides are really good precursors for esters because this acid anhydride can go on to this ethanoic acid can go on to react with more of the alcohol to make more ester. So you get two for the price of one. Okay, that's all for today. Feel free to go through and watch again if you didn't quite get to make all the notes the first time round. I shall see you on Friday, where we'll be making our own esters.